Hello everyone, hope you're having a great day. In this video, I'm going to test these two gears that I have created using a gear template I have created previously. In my previous video, I have shown how to create a gear having involute tooth profile using parameters and the law tool. So to test these two gears, I have created an assembly that comprises of three components. The first one is the pinion having teeth equals to 16. The other one is the gear wheel having teeth equals to 32, and a bridge just to connect these two gears. So the center distance between the two gears is actually the sum of the pitch circle radius of the two gears. The pinion having a pitch circle radius of 24, adding with the pitch circle radius of the gear wheel having a value of 48, giving the center distance of 72 mm. So I have created a bridge that is basically a plate having two pins above it, and the distance between the two pins is 72 mm. The next is to create the assembly. I have created three types of constraints. The first constraint is the fixed constraint that I have used it on the bridge. The next one is the coincidence, just to coincide the axes of the pin and the hole of the gears. And the next one is the offset, so that the gear have a gear joint throughout the surface of the tooth. Okay, so to perform a clash test, first we are going to see if there is any kind of interference between the gear tooth. So in the top view, zooming, we can see there is an interference between these two pair of the gear tooth. So let's see if this interference occurs in the clash test report that we're going to perform right now. So just hide the bridge. To perform the clash test, go to Analyze. Oh, sorry, we are in the DMU. Just go to Assembly Design. Okay. Go to Analyze and click on Clash. You can see some options, Context plus Clash, which we are going to select this one. Between two selections, we are going to select the two gears, that is T16, and the second selection will be the T32. Okay, you need to click on Apply option so that we can observe the report that the clash test provides us. So click on Apply. Okay, so the type is the clash, which is actually the interference between the two pairs of gears. You can see from the preview window, this is shown by the red line, the interference between the two pair. Also you can see from the result window here, if you want to see it in a bigger window and you want to see it properly. Okay. So click on Cancel. We are going to remove this interference using the manipulation option. Click, and you must select the drag around any axis option. Click on it, and I'm going to select the axis of the bigger wheel and go to top view again. Zoom it near the two pairs that have the interference and just move to find a better position for the tooth. Alright, that's seems to be perfect. Click on OK. The next thing is to run the clash test again. So Analyze, Clash. Let's just select between all components and click on Apply. So as you can see, the clash have changed to a contact type because it does not show any more interference as we have changed the position of the gear wheel. In the result window, you can see it better. So now what we're going to do is to create a gear joint between these two gears so that we can simulate a animation of the gear joint. To do that, go to Start, Digital Mockup and DMU Kinematics. To create a mechanism, first what we are going to do is to create a fixed part, which will be obviously the bridge. So click on fixed part, new mechanism, change its name to gears, OK, and select the bridge. So our mechanism has been created, which is named as gears and which have a fixed part, that is the bridge. To create a gear joint, we need to create the Revolute joint first, that is Revolute joint 1 and 2. So you can create from the gear joints option also, but I prefer from the joints option and click on Revolute joint. So the first Revolute joint will be between this pin and the pinion. Just select on the surfaces, offset -10 mm. You must not check angle driven. Click OK. The first Revolute joint has been created. The next will be of the gear wheel. Click on Revolute joint. First select the axis of the pin, hide the bridge so that we can select the axis of the gear. Now select the surface of the pin. Select offset, and which is 10 mm. You must not check angle driven again. Okay. Now it's time to add the gear joint. Gear joint. Select the two Revolute joints that I have created, first, second, and select opposite, so that when we simulate, the two gears must rotate in opposite directions. The ratio is actually the gear ratio, and the negative sign only represents the opposite direction of the two gears. So change this ratio to 0.5, as the number of teeth is 16 over 32, which is 0.5. Click on OK and select simulation with commands. Okay, it gives an error, add at least one command on a joint. So we have not added a command, so go to gear and select angle driven for Revolute 1. Check it, click on OK. You get the information, the mechanism can be simulated. Press OK, collapse the application and go to simulation with commands again. So just click on play button. First we are going to hide the bridge so that we can observe the animation better. Okay, go to simulation with commands, hit play. So as you can see, we don't see any interference between the two gears having a gear joint. Thank you for watching. Have a nice day.